Okay, so we're going to wrap up week 2 by talking about interactions of energy systems. And we're also going to talk a little bit about oxidative characteristics of muscle. That's like one slide. Okay, so here are the goals for this lecture. So take a minute. What do you see in this graph? Okay, so we've got 3 energy systems here. So we've got phosphagen, or this is also the ATP PCR. Okay, glycolytic, so glycolysis, and the oxidative, so electron transport chain. All right, so a few things to keep in mind here is that, first of all, the energy systems are not activated sequentially. So what we mean by that is that when we start to exercise, they all are activated. Okay, it's not like we wait for ATP PCR to be all the way used and then glycolytic starts, and then after that's all used, then we use the oxidative systems. They're all activated at the same time, and they're all active all the time. Okay, but they've got different levels, right? And so at the very beginning, the electron transport chain, we're not generating a lot of energy there. Okay, glycolysis, after about a minute, minute and a half, 2 minutes, we're only getting about 20% of our energy from there. ATP PCR, yep, it's almost done, but there will always be energy generated from that system. Okay, so they're all active at any one time, but depending on what we're doing and how long we've been doing it, that's going to change the contribution. Okay, and so really at the beginning here, there's a tiny bit of glycolytic and tiny bit of oxidative, but it's essentially the ATP PCR. Okay, even during intense or long duration intense exercise, oxidative is 80%. Okay, but we're still getting stuff from glycolytic, and we will still be getting a tiny, maybe negligible, but the ATP PCR system will still be active. And so this is related to the crossover effect. Okay, so we've got two lines here, and just think of the y-axis as like percent contribution. Okay, so we'll say this is 100% up here, and then obviously at the bottom it's 0. Okay, and so we've got intensity going from low to high on the x-axis. Now, at the beginning, and while you're sitting here watching this video, your primary fuel source is fats. You're using fat. Okay, and that remains the case until about 60% of max. So we're going to say right here is 60%. Okay, at that point, we go from relying on fats to relying on carbohydrates. Once we get above 60% of max, we're relying on carbohydrates. Okay, so max exercise is a carb burning thing. Low intensity is more of a fat thing. So why carbs during high intensity exercise? Okay, we talked earlier, I've only got 2,500 calories of glycogen or in my glycogen stores, whereas I have 70,000 in fat. It would seem that during high intensity exercise, I'm going to rely on fat because I've got so much energy. Well, remember, and part of the reason is that one fatty acid produces about 3 times as much ATP compared to a glucose molecule. The problem is, and I mentioned this, whether or not you caught it, I don't know, but that fat oxidation occurs slower. It takes longer. Okay, so just think about high intensity exercise. What's the hardest thing you've done? Imagine doing a mile race or a 5K race, okay? Like where you're legit racing, you're giving your all to run that mile or 5K as fast as you can. That's high intensity aerobic exercise. You're using a lot of carbs, okay? And so even though I don't have as many carbohydrate stores, I can break down carbs much quicker. And so I can generate or I can liberate that energy so I can keep doing what it is that I'm doing. Okay. So fats, even though I've got lots of fat, the breakdown of that fat is slow. Breakdown of carbs is quicker. So I use carbs during high intensity exercise. And so we're going to tie this into type 1 versus type 2 fibers. And we're going to talk about this again in a couple weeks. But when it comes to their oxidative capacity, okay, type 1 are considered oxidative. They require oxygen to function. And the way that they're designed makes them able to use this oxygen compared to type 2. Type 1 will use oxygen a lot more efficiently than type 2. Okay, and the reason why is they've got lots of mitochondrial enzymes. They've got lots of mitochondria. Their mitochondria are bigger. There's lots of capillaries and lots of myoglobin. Okay, and when we say mitochondrial enzymes here, really what we're talking about is type 1 have a lot of the oxidative enzymes. Okay, so like Krebs cycle, electron transport chain, whereas type 2 are going to have more of those glycolytic enzymes. Okay, because they don't need the oxygen. When it comes to, remember, the mitochondria is where this oxidative processes occur. So type 1 fibers, because they can use the oxygen, they have lots of mitochondria. They have big mitochondria. They're able to use more oxygen. But in order to be able to use more oxygen, they've got to have an ability to get that oxygen in from the bloodstream, and so they have lots of capillaries that go to these fibers. And then the myoglobin is also important because the myoglobin gets the oxygen from the inside of the cell to the actual mitochondria. It's like it's the transport shuttle. Okay, and so this is why type 1 fibers are more oxidative. Or this is what makes type 1 fibers more oxidative, is that their anatomy, their structure allows them to take advantage of that oxygen.